Hello everyone, I am Nabil. In today's video, I'm going to talk about a project that I've been working on for my UVCOM course. In this project, we are trying to design a forecasting model for average speed of Uber rides at different roads of New York City. After predicting the speed, we are trying to find out when the prediction fails or when the speed of a road is not what we thought it would be. And then we will try to find out if the anomalies in the average speed is related to weather condition or maybe any local events. The dataset we used had average speed and standard deviation for every road of New York City for each hour of 2018 and 2019. We considered any connected starting and ending point as a individual road. So point A to point B is one road and point B to point A is a different road. We found that there are around 120,000 different roads, and we decided to select only the roads that had data for at least 90% of the hours. We found that there are roughly 10,600 roads that met this condition. So if you look at the graph here, each bar represents the number of road that had data for 10%, 20, 30, up to 100% of the hours. So we only selected the last part, like 10,628 roads for our analysis. After processing the raw data, we selected 10 roads and plotted the average speed against the hours in a year. The graph on the right shows that for one road, here each color represents different months. The graph on the left shows the zoomed in section, and here we are just trying to see if there is any pattern for average speed, and we can see that there is a daily pattern in the average speed data. To get a better understanding of the daily and weekly pattern, we decided to plot average speed of a week and a day for the whole year of 2018 for individual roads. And from the top two graph, we can see that during weekends, the average speed is slightly higher than the weekdays. And from the bottom two graph, we can see that between 6 and 9 o'clock, the speed is much lower than other times. And also during 5 or 6 o'clock, the average speed is much lower than rest of the day. The red orange line shows the speed during weekends, and the blue one shows the speed during weekdays. And as expected, during weekends, the average speed is slightly higher. Autoregressive models are most commonly used for forecasting time series data, but since we are trying to find anomalies in average speed data, the autoregressive model has a drawback in this case. So we cannot find anomalies that is going on for more than a few hours, since the model predicts the current speed based on the speed of previous hours. So we decided to use harmonic regression, which is a linear regression in frequency domain. And if you see the FFT plot on the right, you can see that the most significant frequency is 1 samples per day. So that basically says that the data is repeating every 24 hours, and it also repeating every 12, 8, and also 160 hours. So we decided to select top 40 frequency components for our model. This graph compared the actual speed to the predicted speed. The blue line is the actual speed and the orange line is the predicted speed. We trained the model for 10,628 roads using 2018's data and tested it using both 2018 and 2019's data for individual roads. And we can see here the mean absolute error and root mean square error. And as expected, the error is slightly higher for 2019's data, since the training and testing data was different in that case. The next step will be to find anomalies in speed data. So basically any difference between predicted and actual speed that is higher or lower than ±2 standard deviation. Then we will try to see if when the anomalies occur, and also if they are caused by weather condition or local events. That's all I had for this presentation. Thank you.